everyone. This video would focus on conic section, specifically on ellipse with center at 0, 0 or point of origin. And this is the second part. In this part, we're supposed to sketch the graph of an equation of an ellipse in general form. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at 0, 0 or point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis, that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex. And we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under, or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that, again, our A is always greater than B. Now, to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now let's go back to the problem. Okay, in this example, we are given 81x squared plus 25y squared equals 2025. In order that we can change this to its standard form, what we do is we are going to make this right side of the equation equal to 1. We can do that by dividing 2025 to each of the two sides. So I'm going to show the work up here. Okay, dividing this 2025 divided by 2025 is equal to 1, and that's what we wanted so that we can come up with the standard equation of an ellipse. Now we have 25 and 2025. 25 goes to 25 one time, so we can just have y on top of it. That's y squared over 2025 divided by 25 is 81. So I'm just going to write that down here. Then that's plus x squared as well up here. This 2025 divided by 81 would be 25. So I will write 25 up here. Okay, so what I did here was 81 divided by 81 is 1. 2025 divided by 81 is 25. And in this case right here, what I did was 25 divided by 25 is 1. And then 2025 divided by 25 is 81. And that's how I got this value. Okay, in order to determine which case of an ellipse this is, we look at the denominator. So looking at these two values, 25 and 81, 25 is bigger than 81. We can therefore say that our 81 is our a squared and our 25 is our b squared. Remember, a squared is always the bigger value in the denominator. And so we have 81 is bigger than 25, and that is our a squared then. Looking at this, since our bigger value is under the y squared, remember y is either up or down in the axis. So then we can go ahead and say that this is a vertical ellipse. Now, looking at this equation further, we can say that the center of this ellipse is at 0, 0. So I'm going to write that down here. Okay, so we can sketch the center right here at 0, 0. I will label that as letter C. Now, we are going to determine the value of A and the value of B. So, looking at this, we can say that our A squared is 81 and our B squared is 25. So, I will write that down here. So, A squared is 81. So, then we can go ahead and say that our A is plus minus 9. And then our b squared is 25. So then the b is then plus minus 5. So others are going to say, how did you get that value? I just got the square root of 81, so that's plus minus 9. The square root of 25, so that's plus minus 5. Now we remember that our A is the distance from the center to the vertex and our B is the distance from the center to the co-vertex. So I will label that down here. Okay, so then we can go ahead and say that since this is a vertical ellipse, because the denominator of the y squared is bigger, so then we go ahead and say that we go up and down 9 places. So I will put that up here. So that's 9. So this is our first vertex, and the other vertex is gonna go down here. So that's plus 9 and minus 9 from the center. And then after that, we will go 5 to the left and 5 to the right for the co-vertex. So this will be labeled as co-vertex, and this is another co-vertex. So we can go ahead and say that this ellipse is a vertical ellipse. So that means it's elongated on the vertical axis. So I'm going to go ahead and draw that ellipse up here. Okay, so let's fill these blanks in, the coordinate of the two vertices and the coordinate of the two co-vertices. Okay, to determine the location of the two foci, we are supposed to solve for C, because remember, the distance from the center to the focus is represented as C. So I'm going to show the work down here. So we were able to solve for the value of C, which is plus minus 2 squared of 14, or that is approximately 7.48. So what we do is we go up 7.48 and we go down 7.48. So this is where the focus is going to sit. So that's the first focus right here, 7.48. So this is our first focus, and then the other focus would be right here. So this is our second focus. Now we remember that the two foci and the two vertices should be on the same line segment, which is the major axis. So I'm going to write the coordinate of the two foci up here. So this is the standard form of this ellipse that we have right here, and this is its corresponding graph. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so let's go over the problem here. Since we want the right side of this equation to be equal to 1, so then we can go ahead and move this constant to the right by adding 1024. So I'm going to show the work up here. Again, our target is to make the right side of the equation equal to 1 so that we can go ahead and divide 1024 to all of these. Okay, so we already have the standard form of this ellipse that we have right here. So what I did here was that I divided 1024 to all of these terms right here so that we can have this right side equal to 1. And so the reason why this is 1 right here is because 64 divided by 64 is 1. 1024 divided by 64 is 16. And then the same thing for this. 16 divided by 16 is 1. And then 1024 divided by 16 is 64. And so we got these values. Now, we determine what case this is. In order that we can do that, we're supposed to look at their denominators. Let's see which is the bigger value. Between 64 and 16, 64 is bigger. So this means that this is actually our A squared. And our 16 is our B squared. So remember, the A squared is always bigger than the B squared since it is considered the major axis. So then we can go ahead and say that since 64 is below or the denominator of x squared, remember x is left or right on the axis, this means that this is an example of a horizontal ellipse. So I'm going to write that up here. And the center for this ellipse is at 0, 0. So I'm going to write that right here, or at the point of origin. So I can go ahead and sketch that center right here, which is at 0, 0. Now we are going to determine the value of a. So again, a squared is equal to 64 and b squared is equal to 16. So I'm going to show the work down here. Now we remember that this A is the distance from the center to the vertex, and then this B is the distance from the center to the co-vertex. I'm going to label that down here. Okay, we can therefore go ahead and say that our A is plus minus 8, and since this is a horizontal ellipse, because the value under the x squared is bigger, so we go left and right 8. So this is our first vertex, and this is our second vertex. And we are going to determine the coordinate for this, and I'm going to write that up here. Okay, now we determine the Co Vertices. Now B represents the distance from the center to the co-vertex. That's 4. So plus 4 up and down 4. So this is the first co-vertex and this is the other co-vertex. And so I'm going to write the coordinate of these two co-vertices up here. Okay, so then we can go ahead and sketch the ellipse. Okay, now let's determine the location of the two foci. Now we remember that the location of the foci is C distance from the center. So I'm going to show the work up here. Okay, so the location of the focus is 4 square root of 3 distance from the center, or that is approximately 6.93. So I'm going to count 6.93 right here, almost 7. This is the first focus. And then the other focus is 6.93, almost 7. And that's the other focus right here. That's the reason why we have a plus and minus. So then I'm going to write the coordinate of these two foci up here. Okay, so we have graphed this equation right here, and this is its graph. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!